Hello everyone, welcome to another session on C++. Today we're going to talk about assignment operator overloading. So here, to demonstrate this, what I'm doing is I have created a class called as class A, and I have put everything to public so that I'll have high visibility in my client application. This is not recommended to have data members as private as public, but just to demonstrate the intent of this assignment operator overloading, I'm just putting it into public space. So what I have here is I have a data member called as instar data. Then I have a constructor which accepts an integer data, and then what it does is it just creates a new memory location for the data and then puts the value of the data that has been passed from the client to the address that is freshly created. Then I have a destructor here which is doing nothing but deleting the data member that we have here. So this is all about the class that we have for our demo. Then let's go to the source application. Here I'm going to just create an object by passing in a value called as 5. So what will happen is 5 will be set for the new address that will be created for the data member which is for OB1. So let me just create another object here called as OB2 and I'm going to give a value of 10. So here the same thing will happen for OB2. A fresh address will be created for OB2 and 10 will be assigned to that address. So let me just show you. I'm just going to write OB2 equals to OB1. The moment I'm going to write this, you can see there is no error over here. That means this is acceptable. The reason why it is acceptable is because this equals to has a definition given by the compiler itself. You can look at the definition here. You can see here the definition is given by the compiler, and you can see here what the definition says is this is saying like a scope resolution operator equals to is returning a reference, and what it takes is a constant a reference. So this is what the compiler gives you by default. That's why you don't have to implement the equals to operator every time. Now let's see if we believe on the default equals to operator, what will happen. So let's try to debug the code to understand that. So let me just start the debugger. Okay, so let me get inside OB1. So it is going to take me to the parameterized constructor and I'm going to press F10. So here what I'm going to do is I'm going to create an address. You can see here a new address has been requested and we are successfully created address for the data. And if you can see here, the address is this, and I'm going to put it into my memory debugger to show you. Okay, so there is something junk value given by the operating system. So the moment I'm going to copy the data into the address, you will see this value will be updated with the value that has been passed by the client. Let me just press F10 to show you that. You can see here we are having the same address and that has been updated with a value which is 05. So good, whatever we have passed in, that has been set to this address. Let me just press F10 again and F10 again, pressing F11, and here what we are going to do is we are going to store 10 into the data of the OB2. Let me press F10 again. So if you see, we have created a fresh new address, and with this address we are having some junk value that has been given by the operating system. So let me just show you that yes, this is something junk value that you have. The moment I'm going to press F10, you can see 10 will be stored into that address. You can see here 0A. Let me just show you what 0A means. So I have this A selected here. You can see the corresponding decimal value is 10, which has been set by the sent by the client. Now let me press F10. So here what we are going to do is we are going to utilize the default assignment operator given by the compiler itself. So what will happen with this? Let me just press F10. So if you see here, now OB2 is connected to to the address C90 and holding the value as 5. Let me just put it into the debugger. So you can see it is having 5 and OB1 is also having C90. Now this is concerning because if you have the same address shared by two variables, then both are tightly coupled. Now any changes I'm going to do on OB1 is going to be immediately reflected to OB2 and vice versa. So let me do one thing. Let me just do one thing. So this is my data. I'm going to just store a value of, let's suppose 50. Okay. Now the reason why I have given that as the visibility as public is because I wanted to access this data directly into my client application. So let me just take you to this particular line directly. So I have started the debugger again. Let me take you there directly. So I'm just going to put F5 and I'm going to say, so as we have seen in the last case that OB1 and OB2 both share the same address. So you will see the implications now. I'm going to press F10 over here. So OB2 address is C90. Let me just copy that address. So let me just copy that address and paste it here. So you can see here we have a value called as 32. Now what is 32? You can go to here and write here 32. And you can see the decimal value is 50. So we have set a value of 50 for OB2.data. Now let me just see what is there inside OB1. OB1 is also having the value as 50 because both are tied to the same address which is ending with 9C90. Now this is tightly coupled, which is not a good practice. Now let's try to fix this problem. So the problem that here we are having is the moment I am writing OB2 equals to OB1, it is just doing a blind copy or called as swallow copy. Let's try to do a deep copy where we are essentially going to copy the content but not the reference or the address. So let's try to jump into fix the problem. To fix the problem, what we're going to do is we are going to not touch the client application at all. So we'll keep the client application as it is and we're going to change the class and we'll see how does that make a difference to the client application after we write our own version of the equals to operator. So let's try to write the operator equals to overloading. So I'm going to write a new definition for the operator equals to for the class A. So definitely it will be a member method here. So I'm going to, it is going to accept a object of class A and going to return a object of class A. Very simple. So I'm going to say that constant A reference of OB and I'm going to return another reference. The reason behind giving this as constant is because we don't want the object from where we are copying to get modified. So we are putting constant here, and the reason why we are giving a reference here because we want our application to not create copies every time. The moment I am going to write a ampersand OB, it is just going to use the same address, or it acts like a alias of the object that has been passed from the client application. So let me just write the definition for this. So what we're going to return from here is a reference. So definitely I'm going to return this, the value of this. So I'm just going to write this. Okay, so now what I need to make sure here is this value has been getting updated over here. So the first problem that I have here is I am sharing the same address for OB1 and OB2. So what I'm going to do is I'm going to create a new address for the new data member that we have here. So what I'm going to do, I'm just going to copy this and create a new address for that. So a new address has been created for the data. Now since both OB1 and OB2 has pre-existing addresses for the data, I need to make sure that I'm deleting the previous address that is there with the data. So what I'm going to do, I'm going to write delete this data. So that makes sure that I am giving the memory back to the operating system so that I can create a new memory here. So here I'm creating a new memory. Before that, I'm returning the memory which was there with the OB2 data. So let me just show you now what we have achieved is we have deleted and created a new memory. Now we are going to play around the object of OB1 which has been passed in here. Now what I'm going to do is I'm going to extract the value of data. So I am having some data in the data here which I'm going to extract it into a temp variable. So let me just put it here. So if I'm having a value of 50, 50 will be copied to temp. Now what we are going to do here is I'm going to set the value of this with the value that I get from the temp. So let me just do that with temp. So it looks good for us. Now we have deleted the memory which was there with the data for OB2. Then we have created a new memory location for the data for OB2. Then what we are doing is we are copying the value from OB1 into a temp variable so that we can set the value to OB2. And here this is just a data, not any address or reference. So we are safe in copying the data in a deep copy way, not a swallow copy. So this is being done. Now are we done with the implementation? No, because if you look at this, what if somebody is trying to write like this? If somebody is going to write like OB1 equals to OB1, in that case we know like both shares the same address. So we should write a small piece of code here to handle this. So what I'm going to do is I'm going to check. Now this is the address of the OB2 and it is going to check like if it is not equals to OB, then what you do, you write this code. Okay, let me just write it over here. So here I'm just going to check with the address. So I am just writing like this. So this not equals to OB. So we are just comparing the address of OB2 with address of OB1. And if it doesn't match, then what you do, you go ahead and write this up piece of code. And if you see, okay, OB1 equals to OB1, somebody is writing, just return the object that is being copied. So it is safe for us. So now we are good. So this corresponds to OB2 and OB corresponds to OB1 in the previous example that we had. So let me just take you to here and show that how we have handled this case. So as I told you, we are not going to touch any of the client application. So this is what the application that we had earlier. Let me just put the debugger again. So now I'm going to just press F10 because I don't want to take you through the old code. So now there is a implementation that we have for the equals to operator. So I'm going to take you to that. Let me just put continue here. So the moment you have that equals to, you are going to get a hit here. Now let me show you what is happening. So in this case we are writing OB2 equals to OB1. So in this case we are having two different addresses. This is the address of OB2 which is ending with 2B0. This is the address of OB1 data which is ending with E280. So both are sharing two different addresses. So we are good. Now let me just show you that what happens. So we are having some data here. Let me show you the data So you know, like OB2 is already sharing a value of, is already having a value of 10. So let me just show you that. So A0A is the hexadecimal representation of 10. That means this address is not empty. This address is not empty. So what we are doing here is we are going to give it back to the operating system. Okay, now we don't need this memory, so take it back. So you can see here, now the operating system has put some junk values for that address. Now what we're going to do, we are going to ask the operating system to give us some new address again. So this is the line which will do that. So you can see here, operating system has given us some free memory, and now what we're going to do is we are going to basically take a backup of the data which is inside OB. So let me just show you that. What we have done, we are having a value of 5 which is inside a integer. Now what we're going to do is we are going to copy this value into data. Let me show you that. So now if you see the address, we are having 5. Now let me take you to the next line. So now you will see the difference. What I have done is I have put ob2 dot data with a value of 50. So you can see here I have put a value of 50 and the address is ending with E2B0. Okay, now this is interesting because you will see the difference here. So I'm going to put that address here, and it is having 32, means it is 50. 32 is the hexadecimal number and 50 is the corresponding number for decimal. Now let me show you OB1. Now OB1 is having a value which is E280, which is different. So if I show you this, you can see it is still having 0.5. Even though I updated the value of OB2, I didn't tamper, or I didn't basically corrupt the value of OB1. Now the tight coupling that was there between OB2 and OB1, that has been resolved. This is how we need to implement the assignment operator. So when it is imperative, the moment you have a reference or a pointer, the moment you have a reference or a pointer as your data member, it becomes mandatory for us to implement the own version of the equals to operator. If you don't have such things in your class, you can still go ahead with the default assignment operator that is given by the compiler. So that's it for today about assignment operator overloading. Thanks for watching this video.